let's just double check. What did the directions say here? So in these kinds of problems, we're trying to verify, right? So verify the identity means we're trying to go from this side and get to this side. So this side to get to this side. So I don't need to write these out because these were solved. Here we go. Let's just look at the technique. So here, I already have things in. When I have things in terms of sine or cosine, I'm generally not going to want to change it out of sine and cosine. But what I do want to do is I want to try to see what happens if I use the opposite here. So this is 1 minus the sign. If I multiply, remember I can multiply anything by 1 and not change it. So if I multiply this by 1 plus the sign and the same in 1 plus the sign, then I'm going to end up with 1 minus sine squared in the denominator, and I have 1 plus the sine squared in the numerator. Now, I could multiply that out, right? And so you might say, well, 1 plus sine x times 1 plus sine x, but because you know where you're trying to get here, you're trying to get something inside squared, and look, I already got something inside squared. It's not exactly what I want yet, but let's just see what happens. So the bottom becomes, right, if I do 1 times 1, that's 1, and then I have sine x plus sine x minus sine x, so that cancels, and I end up with sine squared x when I multiply sine of x times sine of x. And that's nice because this becomes cosine of x, using a Pythagorean identity. And that's where, wait a second, now this is something squared, and this is something squared, so I'm going to put the squared out top. And the sine of x over the cosine of x is tangent, right? I can pull this apart, just like if you had 1 plus 3 over 2, right? It could be 1/2 plus 3/2. So that's what they're doing here at the very end. This is 1 divided by cosine, which is secant, sine divided by cosine, which is tangent, and the squared is outside. All right, so if I see something that's already in sine of x, but it has something in the denominator, maybe a good strategy is to multiply everything by 1. Which one, right? Because you could do anything. Well, just pick the opposite of this because you know it's going to cancel out the middle term. All right, 87, we're looking at this quite differently because this is not in terms of sine of x and cosine of x, so it's got no squared, so we can't use Pythagorean identities. So when I start to think, what could I do with it? Well, the first what could I do with it is I can write these two in terms of sine and cosine. So 1 divided by sine of x is the cosecant, and cosine of x divided by sine of x is the cotangent. Oh, that's nice. They have the same denominator. So if two fractions, right, if I'm adding 1/2 plus 5/2, I can add the two numerators and leave the denominator the same. So now I have 1 minus cosine of x divided by sine of x. And now they're using the same idea, just in reverse, right? Well, what else could I try with this? The only option I have is to multiply this by 1 plus cosine of x, and let's see what happens, right? The numerator, I get 1 minus cosine of x, or cosine squared of x. The denominator, I'm just leaving it as is, right? Just sine of x times cosine of x, because that's the multiplication. Pythagorean identity says this can become sine of x. Ooh, now this is tricky. Where's the 1 come from? Well, sine squared of x divided by sine of x is 1 over the sine of x, right? And then I have they're factoring it out. It's like I can't write here, but if I took this out of here and then I factored a sine of x out of it, right? So this one is super tricky on what they're doing here. So they're factoring out that sine of x, and then they have, where? Then they're remultiplying. So they factor it out to get this sine squared out, and then they're going to redistribute. So then they're going to multiply this times this and this times this to get to where they're going. A very tricky one right there. If you need me, I can, if you just kind of write this out, you'll kind of see what's happening here. So I just can't write on this board very well, but I'll write it down a second one in a non-video. All right, last one. Again, we have something to start with that's not in sine or cosine, so a good strategy is to put it in sine or cosine. So the secant is 1 over the cosine. This is just still minus 1 minus 1. Here the secant is 1 over the cosine, and then I have plus 1. This one is interesting because they know that you're trying to get to this tangent. So they were thinking, okay, I need to create the sine over the cosine to get to a tangent. That's why they chose the 1 that they chose this time to multiply it by is the sine, because then I end up with the sine over the cosine minus the sine, right? You have to distribute this times this times this, and same thing in the denominator. And then I end up with the tangent minus the sine and the tangent plus the sine, right? So how did they... What was the thinking? Well, first, let me see what happens when I write it in terms of sine and cosine, and then they're looking at where you're looking. I'm trying to get to the tangent, so if I have the cosine, how might I get to the tangent? Oh, if I multiply everything by 1, but in this chance, the 1 is the sine divided by the sine. So tell me if you need me to write out the steps they did here in 87, but if not, I think that should help.